Good afternoon, everybody. Fusion Phil here. Today's video, I'm going to show you why either if you have a fourth axis or if you're looking at purchasing a new machine that you should get a fourth axis when it comes to reducing setups and ease of programming with Fusion 360. Let's jump into it. So as you can see, I have my part file already open. If you guys want to see how I did this based on 3-axis work, you can go ahead and check out my Milling Monday video. However, we're going to treat this as if we're going to do it on a fourth axis rotary and see how much we can do with the minimum amount of setups possible. So as you can see here, it actually took me 3 setups to do everything initially. So what I'm going to do, and this tends to make a lot of people upset, we're going to take everything and scrap it and start fresh. I am also going to turn off this patch that we went ahead and put in there because we don't need that patch anymore. So let's go into my bodies area and get that patch taken out of there. So what I like to do is I always like to estimate what I want to do or try to proof of concept a few things before actually having to do them. So I'm going to go in and I'm going to create my setup. I'm actually going to go Z up this direction this time. So we're going to go ahead and we're going to pick our Z axis. We're going to put Z up. I'm actually going to run my X axis along the part. And the reason for that is if you think about it, is if I come in this way, and again, this is just my chips are going to fall towards me, is if I come down, I can hit everything on this face, I can tilt down, I can do anything I need to do on these slots on either side, and I can basically conquer this part with the exception of what is going to be the hat, all in one shot. So let's go ahead and walk through that. So I do need a center of rotation. Again, I'm just temporarily placing this to a rough spot because we're going to design a jig and fixture also for this very quick and rapid. So as you can see, I have my stock size. We're going to go ahead and fix size box that. I'm going to bump the size up here in the Z at least. Let's say that's 1.75. I want to offset from top. I'm going to make my external stock a little bigger too. So let's go 175 by 175. And this is just to show you much bigger tool paths and things that are going to flow outside of that. So we're going to go ahead and offset from the top. I'm going to give it, maybe 20 to clean up. This is pretty easy square aluminum stock. And now that I have that all set up, I'm going to go through my normal typical process. So we're going to go adaptive clearing, and this is 3D adaptive clearing. We're going to give it a 1/2-inch end mill, aluminum roughing, and I'm going to go ahead and just let this thing kind of do what it normally does. And as you're going to see, we're now roughing out that hat. If you guys didn't know, you could actually change your bottom height. I did do some parameter work with this on another video. Again, as if we go back into my expressions, I'm using vertical stock times -1, and that's just allowing me to drop that automatically to get to the bottom of the part. If I wanted to go more than that, I could go more than that. It's not a big deal. So now that we've roughed that out, let's go ahead and hit the floors. So I'm going to go 3D horizontal personally. And we're going to go ahead and again, the only thing I'm going to do is I am going to leave stock on the walls. I like to always leave a little more than what we did for roughing just to make sure that we're not rubbing those walls. Cleaning up our flats now, that's looking good. And let's go ahead and go in and just do a 3D contour. And we want the tool to go outside of boundary. And then from that, again, we're going to go ahead and change our step down here because we know we can get away with a much bigger step down. And let's see what that gets us. So as you're seeing, we're going around the outside of the part. I want to make sure we're not roughing out that hole to start with when we come back. So we're going to come back and we're actually going to bore that before we do our contouring. But as you can see, we're getting almost everything. Let's get rid of that helix. Again, we go to the linking because that's in the red moves. So we go down here. We're going to go ahead and say we don't want a helix. We could just plunge. We're outside the part. It's not a big deal. And I'm going to go in and let's go 2D bore. So as you're seeing here is we're going to pick our circular face. We're now boring that out. I'm going to go ahead and place that bore above my 3D contour. And let's go into 3D contour real quick and kick on rest machining. So now we should be avoiding, and we are avoiding this guy here. However, we're getting a little bit of a problem around this outside arc where it's having a hard time recognizing and seeing that there's actually material here that we need to clean up. So let's go back to our 3D contour. We're going to go ahead and adjust the stock to a much smaller entity. Let's go down to 5 thou. And as you can see, by changing that dimension, we've now come all the way around the outside of that loop, making it nice and easy. Again, just try not to bore you guys to death. We're going to go ahead and hit our drilling. Again, that's a 138 drill. Let's go into my drill library. Here's a 136, aluminum drilling. We're gonna go drill tip through bottom, 20. And oh, we forgot to check select same size diameter. So as you can see, relatively simple. We're doing everything based on 3D. The real trick is now is when I want to come in from the side and I want to actually do anything on this backside, like cut these slots, this is where the advantage is going to be. So what I'm going to do now is we're going to go ahead and switch, and I'm going to do a 2D contour, and we're going to go out and pick a much smaller tool. So I have this 1/8 inch flat end mill. Again, we're going to go aluminum slotting this time because we are going to just helical down. And let's go ahead and pick our contours. So the first thing I need to do is I need to do a tool orientation Z this way. I need to make sure my X is still pointed the correct direction. Let me get you recentered up here. And now what I'm going to do is I'm going to go through and I'm going to pick the pocket chains. So as we're going to see here, we're going to grab this chain and this chain. I do know off the top of my head, I am actually just going to ramp down at 2 degrees. I really don't need a lead in and a lead out here. However, if I was using wear, I would turn that on. But as you can see, we're now helicking down. Again, I made the mistake of my heights. Cool thing is it's easier to go back instead of guessing the first time round. So let's go ahead and go model top. We want to go to that selected contour, -20. And now you can see we're now starting a little shorter to the top, saving that cycle time, and then poking all the way down through the bottom. So if I was to simulate this as is, so let's go ahead and hit that machine simulation. I don't have a machine selected, but we are going to give this a machine. I'm going to give it a very quick run through just to make sure that nothing crazy is happening and that we didn't miss anything. So that's actually looking exceptionally well, and I'm almost impressed that we didn't miss anything. We could always go back and do our chamfers and things of that nature, but the key element here is now that we've kind of got paths on our parts and a concept of what we want to do, let's go back and design a jig to hold on to this, and then let's go ahead and send it through machine simulation. So what I'm going to do is I'm going to jump back to design, and now I'm going to create a brand new component, and this is going to be my jig. And now how you design your jig is going to be on you and based off your machine and what you have going on. I'm actually going to do something relatively simple. So I'm going to go ahead with a sketch. I just pick my plane pretty much like normal. And then what I'm going to do is I'm going to figure out roughly what kind of round stock I could use. So I'm doing this based off the idea of something I might be laying around in my shop. So I have a 3-inch piece of round stock that's looking pretty good. I'm actually going to move over this way a little bit because I'm going to more or less notch out this piece and then use a mighty bite or something to hold my part. So with that mentality and concept, what I may also want to do to make life easy, let's go ahead and I'm misclicking here a little bit. Let's go ahead and drop a rectangle of roughly what our stock size is. So as you can see, if this is all the bigger my stock is, then I really don't need a giant 3-inch piece of material. So maybe I could go with, like a 2.5 if I had that, or even smaller. Again, not a big deal, but the idea is I'm just looking to hold on to the flat here, right? So where my stock is going to sit in reference to my part, I'm going to utilize a few dimensions here to set that up. So let's go ahead and just offset this. So let's say we're 0.5 off of there. And again, I'm using this corner here in the origin or the corner of my part. Whoop, let's go back and go up. Let's go 0.75. So this looks a little ugly at the moment, but the nice thing is we're using this to design our jig based off everything that we want to do. So again, as I'm just putting a nice little flat across here, the idea is we could use mighty bites or something to hold on to this. Again, this is a very generic drawing, and the idea of this drawing is going to allow me to create more or less the flat to hold on to my part. So as you can see, here's my part file. Here's that first half moon out of my 2.5 stock. I need to go ahead and get that sketch turned back on because we're going to actually do a little bit more extruding here. So let's say, for example, we have some space this way. And then I'm going to repeat that extrude one more time, and we're going to take now the extrude. And this is going to be 2-sided. And let's go ahead and pull that other side back. There we go. So as you can see, all I've really done is built out a pocket to kind of hold on to my part. And now what you're going to do with how you guys feel necessary, again, everybody's going to be different, right? The cool thing is as always, we have that ability to estimate more and more, to change anything and everything that we have going on based off of these profiles. So as you're seeing here, I'm just adjusting this a little bit more to make this pocket a little bit bigger. Again, I'm going to go ahead and do another extrude, or you could do a push-pull here. It doesn't matter. All I'm looking to do is just open this guy up in any way, shape, or form so that I can hold on to my part. Now, I don't want to bore you to death with designing out this jig. Again, I could create a sketch here, start to model this out even more. The key element is now that we have some type of representation of our jig, when we go back to actually do our setup, in my case, I always use the front face of something furthest away from my actual headstock. You could actually use center of your rotary. So let's go ahead and move our work offset. So I'm going to use the selected point down here. So now we're setting this based off center of rotation. And what we're going to do, now with that center of rotation picked, the other thing I do need to do is I exited out too soon is let's go out and select a machine. So I'm going to go ahead and see what I have here for a Haas with a 4th axis. Again, really up to you guys and what machine you're going to use in your pick. Actually, let's just go ahead and there we go. I saw a 4th axis on the table. We're going to have to download this model. It's going to take a quick couple of seconds here. So let's go ahead and save that. So now that we downloaded and saved our machine, let's go ahead and set our attachment point. So as you can see here, it's looking a little funky to start with, but that's okay. We could fix a lot of this. So what I do need to do is go back to my setup. And what we're missing right now is our actual jig. So let's get our jigs turned on. I'm actually going to add the fixture in so that we can use it. And if you guys want to, you don't have to. You could add a fixture attachment point. It's not a big deal. But now positioning this is where it's always a fun time. So what I want to do is I want to position this based on rotation, right? So again, I'm going to use a selected point, which is selected center of rotation. And again, as if I use one of these edges here, as you can see, we're now rotating around center. And now depending on how far I want this to stick out, that's going to be the trick to make sure that you're not colliding with your 4th. So I'm going to intentionally actually leave this pretty close to see if we can force a collision. And from that, we're going to regenerate our tool paths. And now let's go ahead and simulate this. So, we still got tool path simulating. So let's go back and simulate with machine. So as you're seeing here is we actually have plenty of clearance. However, I'm getting tons of collisions down in my timeline. So we're going to make sure we have stop on collision turned on. We are now getting a verification issue with 35 errors, which is no surprise. And the whole concept is that we are just too close to that headstock for what we're actually machining and setting up. So let's go back and again, let's move that a little bit further away. So the whole idea here, guys, with the machine sim and everything in one shot in the 4th axis world, you can actually go in and you can set everything up and you can simulate it long before actually running it on the machine and making sure that you're not having any problems or collisions. Again, my jig is too close to my stock. This is one that will obviously affect what we do. So we could go once again back to the design side, which I will do here in a minute. I'm just trying to speed through this. So we need to give a much bigger gap between our part and our actual jig for holding. So we're going to go ahead and jump back to design. I'm going to go back down to where we do all of our extruding. And in this case, we're going to extend this a little bit further. I'm going to go ahead and go to that secondary extrude. We're going to open that guy up just a little bit more. And then one thing I am going to do here is we have a couple extra extrudes that we really don't need. And let's just, again, unselect this upper portion of our half circle. And there we go. Oh, we're missing our other half. And the reason for that is because I've extruded it off this end. So I'm actually going to double back up here, guys. There we go. We're back to the way our jig is set. Again, we may have a shoulder in here, and you could fully sketch on this face, which is kind of nice. So if I did want a shoulder in here to hold my stock, I could easily add that on and extrude that up, you know, whatever that distance is, holding onto my material. Again, this allows me to be very conscious about what's going to happen when that machining happens. Again, putting my pockets over here for my Mighty Bite or any way that I'm looking to actually attach and machine. So if we go back to manufacture all over again, we do have to regenerate. And then from that regenerate, we're going to go ahead and simulate this. And let's back up and over to our part. And now we're actually looking very collision free till we get to the end. So this is going to work out pretty good for us for the most part. And we're going to find out why or what happens that we can't quite fully make this. I have a hunch. And there it is. Again, we have a tool that's just not sticking out far enough. But with that, as always, guys, as you can see, it's very easy to switch from, a 3-axis scenario to a 4-axis scenario. And I hope this justifies why you would want a 4th-axis machine or adding a 4th axis to your current machine. Now, that said, as always, you guys have to like, follow, and subscribe to let me know if you like this content or if you're looking for something else. Please leave a comment down below to tell me what you would like to see. And as always, it's not what you know, it's who you know. You guys know us at JitCAD Cam, and you do get our support by using the email down below for any questions and problems you have. That said, have a great rest of your day.